Okay, so hi guys, good evening. Welcome to the first session of robotics. So I'm Harshit Kumar, a student at PS University, second year student, ECE branch. So we'll be heading on to the first session of robotics in under HackerSpace. So the first session will be on introduction to microcontrollers and microprocessor. So this is basically uh, a spot where you're uh, you learn about the hardware components that you might essentially need for the either robotics or IoT sessions or IoT projects. So the topics of discussion in this session is basically what is robotics and what importance does the microcontrollers and microprocessor have in the field of robotics. So since you guys know that robotics is basically a hardware component based domain, so you might need the electronic devices which are necessary for the hardware components to be moving around or you know do some particular task automatically. So, what importance does the microcontrollers have in this field? And then we'll move on to like in depth what are microcontrollers and microprocessors. Probably it won't be that in depth. Like basically what you guys need to know as beginners in this field. And then we'll talk about the differences between microcontrollers and microprocessor. And probably we'll hold some discussion on probably like you know what all sensors can be used with these microcontrollers and microprocessors, and what stuff can be done. So yeah, so what exactly is robotics? So as you guys probably can guess out, like we have like many robots, and you guys might be following up with some projects and other advancements happening in the world right now. Can anyone talk about like what you guys have heard about robotics, or what you guys follow up, something like that? Hello, am I audible?
Yeah, you're audible.
Yeah, can any of you guys speak out the
I think like the field of robotics is aiming to make to use these robots or machines to do human tasks.
right, right, exactly. So the whole point of robotics is to make things that make tasks easy for humans. So you might be knowing that few human errors, like someone is tired after doing a huge amount of work, and eventually he will do some errors in the task assigned. So what exact view of robotics is that how much ever the workload may be, the robot must be able to do with the same accuracy. So that's the whole point of robotics. So yeah, this is about the robotics, and like the microcontrollers and the microprocessors probably play a huge role. You know, like the majority of the roles are played by the microcontrollers and microprocessors. So we'll look into that, what it has to offer. So the microcontrollers and microprocessors in robotics. So when you take up any robotics project, or you do any IoT projects as well, what you look out for one thing is like coding something, and that device, or coding that electronic device which does the work that you have assigned perfectly, right, guys? Should I go slower? Is this fine?
Yeah, that's fine.
Right. So whatever you code into an electronic device, that like most of you know that something has to be coded if you want something to be automatic or automated, or to be working without any human intervention. So whatever you code has to be executed properly. So you can tell that these devices act as a brain for that particular system, right? Are you able to? Are you guys able to follow it? Hello, guys. Let it be interactive,
Yes, yes.
or else I'll sleep off. Cool. So whatever this brain has, so it takes up an input from the, consider our body itself. So whatever we touch or we feel, that the brain transmits it, or the brain receives the signal and transmits some response to that stimuli. So what is stimuli is nothing but the feel of touch, or any sense that you might feel while the physical response. So the brain accepts the input and gives out the particular output for the body to respond to that stimuli. So in the same manner, the robots, the sensors which we attach to the robots, they send particular information that is expected from that particular sensor into these microcontrollers and microprocessors. So what these microcontrollers, according to the input that it receives from these sensor, basically uh, does some calculation, and the control aspect of it does some calculations and comes up with an output which basically is sent to the other hardware components of the robot, which has to work according to that stimulus, or the the work actually has to be done. So consider this. Have you guys seen a humanoid robots? Humanoids, or okay, actuators are those things which, like, rotatory motion components, like DC motor and uh, the 9G servo motors. Okay, Sophia, right? So in yeah, the robots like Sophia, they have like stimulus, yeah, Atlas as well. So though these robots have like foot, they walk around, right? So once they walk, when they walk around, uh, their legs have that some sensors which makes them like uh, know the steepness or the incline in the floor. So what this does is, the sensors at the feet, they find the angle of elevation of the floor, and they send the information back to the microcontrollers. So the microcontrollers detect them and make sure that the whole system of robotics can be balanced, uh, even though there is an inclination, right? So are you guys following me?
Yes.
Yes.
Right. Okay. Hi, Aditya. So Aditya is also a mentor at robotics domain, HackerSpace. So introducing him. So yeah, let's move on. So yeah, as I told, these microcontrollers and microprocessors are basically, we consider them as the brain of robots, right? So they perform the computational operation. So whatever the input we get from the sensors, those are taken in by the microcontrollers, does some calculation work inside the memory, and gives out the you know the actual operational information to those sensors which really needs to work at that point after getting the information. So yeah, that's about the role. So yeah, we have talked about like microcontrollers and microprocessors accepting the information from the sensor and again giving out the information to those specific uh, devices. So what exactly are these microcontrollers and microprocessors? So let's look into that. Are you guys with me? By the way, any questions out there till now?
So is it usually for a robot only one microprocessor or controller, or there's possible that there are multiple ones of them?
Right. A good question there. So a robot can have multiple, microcontrollers and microprocessors. So one example I can give you is in the case of drones. So you can't, like, if you are constructing a bigger drones, you can't just use a microcontroller or microprocessor like Raspberry Pi or Arduino, and just code it with some values and then put it on the drone to fly around. So you can't, like, if you are constructing a bigger drones, basically you can't do that. So you need another thing called as a flight controller. So flight controller, you can basically use it as a another set of microcontrollers. So you'll have a combination of a microcontroller or a microprocessor, basically the Raspberry Pi, and the a flight controller, which is the basically a Pixhawk or something like that. So it will be a combination where both of them communicate with each other and make sure that the drone doesn't crash. Uh,
So I have one more question. What about the ESC in the drone? Like, what component does that? Like, what exactly? Is it a microcontroller or microprocessor, or is it
well,
neither of them?
right. So if you are using it for an automatic, automated drone kind of thing, you might need Raspberry Pi to do the to construct a automated drone. But if you are like going for a manually controlled drone, you might not need any microcontrollers or microprocessor other than the flight controller. So you'll have the control using that uh, the transmitter and receiver, and you can control the drone. That's the thing about it.
Are there like microcontrollers for like specific uses also? Like, actually made for different uses?
Yeah, there are microcontrollers which can be specifically used. That comes under like PCB devices where you alone construct the microcontroller chip as per your requirements. So one of those examples I can give you is the Node MCU. So Node MCU in other terms is like ESP8266. So that is like the inbuilt. It has the inbuilt Wi-Fi module which can be used for the IoT purposes specifically. So those the Node MCU or the ESP8266 can't be used in other specific uh, cases where Raspberry Pi or the Arduino needs to be used. Any more doubts, guys? We'll move on to the next thing. Hello, let it be interactive,
Yeah, I
guys.
can hear you.
Yeah, we can hear you.
Yeah, so we'll go to the next then. So, what are microcontrollers and microprocessors? So, as you can see in the slide, the above one is the Arduino Uno, and the below one is the USB Node MCU with ESP8266. So, what exactly are the microcontrollers? So, consider microcontrollers similar to the any chips like miniaturized computers, which basically which has an which basically has a processor. It has memory and input-output peripherals. So, if you guys look at or observe the Arduino Uno, at the topmost there are numbers. Like there is a black slit kind of thing. So that's followed by a series of numbers. So basically from 0 to roughly 13. So these are the input and output uh, pins which can be used to connect other electronic devices. So this basically has a processor that is the Atmega 328P, and it has a memory which is like a bit lower, which has a bit lower memory, basically just to hold the code which you can put into this microcontroller. So it has the input and output peripherals on the same chip. So it has both RAM and ROM. So RAM is used to store data as well as uh, the other results that can be created when this is basically used in some task, and it controls how particular circuits. So as I told you, when there is a task assigned and you need to give an output to a particular pin, like consider 7. So you the control system in the uh, Arduino microcontroller, that is the RAM, make sure that that particular communication is done through the same pin, right? and the analog to digital converter. All those things are done here. So the ROM allows the microcontrollers to know that certain actions should be triggered particular responses. So once you let's consider like there needs to be a responsive uh, method in the Arduino or the system you are building. So at one side you take the input and the other side you give the output. So let's say like pin 1 takes in the input and pin 2 needs to give the output. So what this does is like once the pin 1 receives in this signal or the input, that is stored in some kind of like memory, that is the ROM, and according to that memory the specific signal has to be sent through second pin, that is pin number 2. So that is controlled by ROM, and the size that can be stored is dependent on the size of the ROM that is used in the microcontroller, that is the Arduino. So some microcontrollers accept ROM addition in the form of external chips, while others come in the built-in ROM. So basically the Arduino Uno has an inbuilt ROM that is like too small, not so big as well. But in cases of Raspberry Pi, so Raspberry Pi, you can't just work on it directly. You need to insert an SD card to uh, you know have the memory space. So Sanket asks, why is there a negative sign in numbers? So basically that's not the negative sign. Those are tilde signs which basically are used for like how can I explain this? So consider you need to uh, do a trans like the receiver and
Arshit,
yeah, yeah, yeah.
if you don't mind, I'll just help you answer that question.
Cool.
Okay, basically consider a motor which has a wheel attached to it, right? So let's say you want to rotate the wheel at, let's say, 40 RPM, and at some point you want to rotate it at 20 RPM. So the amount of power which has to be gone to the motor varies at different instances of time. So at that point, you use something called as pulse width modulation. So basically, it'll transmit signals, electrical signals, in order to get an average power which will be used by you.
Yeah, basically Aditya Mehta is perfectly right. So
So it's basically like a speed controller.
yeah, kind of that. So if you consider like the servo motors, you guys know servo motors, right?
Yeah.
So in the servo motors there is particular angle to be given as the input. So this these pins with the tilde sign make sure that the PWM correct accurately calculates the angle that is to be swept, and make sure that the servo motor sweeps that much amount of angle. So that's the whole point of the uh, pins with the tilde sign.
Harshit, I think it'd be better if you show a picture of a servo motor because I don't think a lot of people know what a servo motor is.
Right, I'll do that. One second, guys. One second.
So what are the different ways we can code robots?
Uh, I didn't get your question though. Can you repeat it?
like Arduino, you code using C, and that's Arduino IDE, and you can also use processing.
Right.
And you told there are multiple other microprocessors. So how do we code all of them?
So basically, the microcontrollers you can code it with C, C++. Basically, the Arduino has its own IDE, right? So once you get into that IDE, you'll there's the syntax is in the IDE itself. So there's a syntax for initiation and the loop function. So you can code with that. Other than that, if you are
So
using like a microprocessor, you can basically code it with Python if you're free to use it. I mean, most of the people find Python to be more versatile to be coding. So, guys, can you see the Tinkercad model here? So this is Tinkercad. Basically, we use it for uh, you know simulating stuff if we don't have the hardware part. So to show you guys, I'm just opening up this. Can you see the screen though? Hello.
yeah,
Yeah. So this basically is the 9G servo motor. So once I start the simulation, right? You guys see that there is a slow motion in the servo motor,
yeah,
right? So if we go into the code, right? So here we see that position this is the loop function over here, and this is the setup function. So setup function is where we initiate the pin to be to give the outputs, and here we use variables like pose equal to 0, less than 180 degrees, and we write it as pose, that is giving the angle, and delay is 150. So this is 150 milliseconds of delay with every increase in angle. So as you see that there is a slow sweeping of angle from 0 to 180 degrees, which shows that there is like very small uh, time delay for every angle. So this is basically the uh, 9G servo motor thing. So here you give the angle as the input. So this is about the 9G servo motor. So whatever you see in the tilde sign. So here, if I zoom in, you see that the tilde signed pin is used to give the output signal to the 9G servo motor. So this is basically the working of the tilde sign. Yeah, so Aditya has sent the link. You can just try it out. Yeah, so 1 second. Yeah, you guys can see the PPT now.
yeah,
So yeah, that was about the microcontrollers. So what extra do we have in the microcontrollers? So in the microcontrollers, we don't use, like, they do not have a particular screen or keyboards to direct like the human computer interaction which we do with the laptop or the PC. So instead what we do is we plug in the uh, uh, the microcontroller using a USB cable basically. So what we use is a USB cable, and we code it to do some particular task, and we upload the same code into the microcontrollers using the IDE. So for coding the Arduino, we basically use the Arduino IDE. You might have to install one to start coding the Arduino. So we'll be covering that in the later sessions. So these So since we don't have like computers or I mean, sorry, the keyboards or the screens to do the human computer interaction, we have like the input and output pins, which I showed you in the Tinkercad model, and we also have GPIOs. So GPIOs generally are present in like the higher end of the microcontrollers, like basically Arduino Nano, or basically in Raspberry Pi you'll see more of these GPIO pins. So GPIO pin is basically which gives if you want to input a graphical input or take out something enormous more than the electronic, the binary signal that is zeros and ones, you can use those GPIO pins. So these are about microcontrollers. Any doubts, guys? Any doubts?
What are registers?
So registers are the basically there are memory bits, right? You remember like we talk about 8-bit memory, sorry, yeah, 8 bits or 12 bits memory space, those kinds. So there are very small memories built into a CPU. Like in the CPUs we talk about the 8-bit CPU or the uh, you know 16-bit CPU, those kinds. Like in short, they are memory spaces, bro.
Okay, okay.
Any more questions? Hello. I'll go ahead then.
Yeah.
Yes.
Yes.
Okay, cool. So we have one more set of electronic devices, that is the microprocessor. So as you can guess, in a way, the microprocessors handle heavy computations rather than the microcontrollers. So in the microprocessors, there are the integral aspects of electronic devices which are equipped with several additional functionalities upon the microcontrollers functionalities. So the main aspect is that the ALU and CU being in the same chip. So in the microcontrollers, there are very basic operations that can be done in the microcontrollers. But in the case of microprocessors, we'll have a full set of uh, the CPU, which includes the ALU and CU, that is the arithmetic logic unit, and the control unit, which is similar to a laptop or a PC. So we'll have the whole set of that into a single chip. So the arithmetic logic unit and the control unit, they make sure that they get what as per the instructions given to the microprocessors, they do the arithmetic operations and the control operations with respect to the input they get and the output they have to send, as well as what data they get and what they have stored inside them. So the memory unit is similar to the microcontrollers thing, where they support RAM and ROM. And registers, as I told you, they are very small memory spaces in the CPU for speeding up the operation. Uh, Sorry. So there are system bus. So basically, bus, you consider it as a connecting wire between certain devices within uh, the microprocessor. So consider it like interact. You need an interaction between the memory and the control unit. That is the operation. Some operations had to be done using the data that is stored in RAM and ROM. So using the system bus or the uh, address bus, we get the information that is stored in RAM, that is the memory that is stored in RAM and ROM, and pass it to the CPU or the control system control unit, where those specific operations has to be done. So these are system bus. Consider it like the connecting wires basically. So these are some examples of the microprocessor and the microcontroller. What you see here, that is the Atmega 328P. So this is a basic microcontroller which is actually installed in an Arduino Uno. So the Arduino Uno, if you see, they have this very small chip naming the Atmega 328P. So this is the whole chip which controls all of the input and output and the memory that can be stored or uh, used up while doing any task uh, in using the microcontroller. And what you see in the right is the microprocessor. So this is the microprocessor which basically is installed in Raspberry Pi, like Raspberry Pi 3, Raspberry Pi 4. So this basically you know uh, contains the ALU and CU and does all the operations, including the heavy computational operations. Like consider you're building up an ML model inside the microprocessor, then you can then this comes into picture and does all the computational work. Right. So let's move on now. Okay. So any doubts, guys? Any doubts as of now? So, hello. Am I audible?
Yes, yes.
Yeah. Any doubts, guys?
No.
Okay. We'll get into the major differences between the microcontroller and microprocessors. So, as you saw, like the microcontrollers, they are used for like very small tasks, which doesn't include any heavy operations or any heavy computations that needs to be done in the case of any you know any control unit, control systems, or any such things. So the microcontrollers are used up for that small tasks, whereas when it comes to microprocessors, they handle a large variety of computations, or I can tell it as instructions that is input from the user for doing that particular task. So yeah, the microprocessor is same as like the whole computer system that you're using and can handle very heavy process. And the microcontrollers have like very small amount of memory which is already built in into that, whereas in the microprocessors you need to have you need to insert some kind of memory devices. Consider it as an SD card basically. uh, Sorry about that. So basically like SD card into the Raspberry Pi, so you can that can be done. So it doesn't have any inbuilt memory locations, even though they have a few registers that is very small memory spaces, but they can't handle any of the computations or the memory that can be used in a particular process. So one more notable difference is that you have seen that in the microcontrollers where I showed you the Tinkercad model, there are peripherals or the pins that or the RAM and ROM into built into the uh, this one what to tell the microchip. So the control bus are used inside of the chip to interface between the RAM, ROM, and the other peripherals, considering that the microcontroller, that Atmega 328P. So that communication between the Atmega 328P and the RAM and ROM in the microcontroller is basically done using the control bus. So the control bus is inside uh, the microcontroller chip, whereas in the microprocessors, you you need to use an external bus to do so. So uh, you have to plug in, since you'll be plugging in the the external memory devices. The microprocessors use an external bus to have the communication between the uh, control unit or the CPU part and the memory that is going to be plugged in. So those are the notable differences between the microcontrollers and microprocessors. Uh, yeah, the example is the Atmega 328P in Arduino and the microprocessor in the Raspberry Pi single board computer. So right, so this is the session about basic introduction to the microcontrollers and microprocessors. In the upcoming sessions, we'll be looking at how do these Arduino or the Raspberry Pi exactly work, and how will you be able to code them to do some particular the task assigned, or probably in short build a robot. Uh,
So,
guys, can you? Yeah, yeah, go ahead.
yeah, also next week there'll be hands-on session. So if you guys have Arduino, then download the Arduino IDE. If not, try creating an account in on Tinkercad and try like just exploring the software. And we'll be having hands-on experience as I mentioned before next week.
Okay. Cool.
Okay, thank you.
Yeah, guys, any questions? Any questions or any queries, including other aspects as well?
Yeah. Anything about robotics?
Yeah,
So where do
I
we
have one
start?
question.
yeah,
One line, please.
Hello?
yeah, go
Yeah.
ahead.
Yeah, so in the beginning, I remember one of you mentioned that the way the Arduino works is that it modulates, it does pulse width modulation on the signals going into, like, for example, the servo motor, and that's how it controls the speed.
Yes.
Correct.
So these are DC signals. How exactly does that work?
Right.
Okay.
So, Aditya, will you explain, or?
Anything, bro. Okay, I'll explain. I'll just
Yeah,
explain.
you can
So
explain.
basically, what happens is, okay, imagine a graph. Okay, never mind a graph. Okay, so basically, what happens is the Arduino gives out current at different instances of time. Okay, so let's say at 2 seconds, the Arduino gives 5 voltage of current, and at 4 seconds, it gives let's say 0 voltage of current. So the average current transmitted to that IoT device or the sensor will be 2.5 volt. So that's exactly how it will be modulating its signals. So basically, like if you google something called as square wave for current and current versus voltage, you'll get an idea of how exactly it works.
Alright, got it. I think I got it. Yeah, we learned about square waves in our EE class.
Yep.
In other words, you can tell that since it is a DC signal, there will be two inputs, right? Only 0 and 1. So, basically, the Arduino gives out the signal with uh, 5 volts at max and 3.3 volts as minimum. So whenever you need, like, consider you need 3 volts, uh, the 3 volts of signal to move the servo motor by some part. So in PWM we make sure that the average in that particular time, I mean the average of the signal at that particular time is 3 volts. So at one instance, if it gives high, that is 5 volts, and other instance it gives uh, 0 volts, the average is 2.5. But the next instance it will give another input or the signal wave, which is like 5 volts again. So there will be certain time intervals where the signal is high, and the other instances where the signal is low. But overall the average will be made sure that it is around 3 volts for the 9G servo motor to the sweep a particular angle.
Uh, yeah. So to answer Arya's question, you don't have to install anything. Basically, go to tinkercad.com. That is, wait, I'll just send the link. Tinkercad.com. Yeah. So you can explore the software. You have time till next week, and then we'll start working on it from the next week.
Yeah.
Cool,
Guys, any
guys.
more questions or any queries? You can be open. No problem.
Yeah, I think that's a wrap.
Guys, if you guys have any other questions, we'll take it up, or
Thank you.
you guys can leave.
Cool, guys. Thank you for
Cool then.
attending.
Thank you, guys.
See you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you guys. See you.
Yeah. Bye bye.